Now, it's not actually difficult, so don't worry. When we do it in semester 2, it's quite easy formulas. Okay. So we have here metal pipe. It's open at both ends. And this distance here is 0.85 meters. Draw a diagram to represent the amplitude of the particles displaced inside the pipe. And it's at its fundamental frequency. Node or antinode here? Anti. And here? Anti. So, yeah, it's like an X. So can you imagine if I had some sand here, where would the sand move? It'd move to the left, move to the center. Yeah, so what you would have is, you'd have some sand kind of building up in the center. So if you were to make a graph here, like this one, this could be X, and this could be the number of sand, the amount of sand. Where would most of the sand be? Should be in the middle. So you kind of have a shape like this. Most of the sand will want to move to the middle. Now, I think I have done more than what I actually need to get the marks, because if I look at their answer, just this graph. So I should say antinode, node, antinode. Oh, sorry, no, wait, stop. That's part 1. Part 2 is where is the node and antinode. So here is the node, and here antinode. No, you can do it. You could do it like this. You can just say node, antinode, antinode.
I thought the antennas had the top and
Technically, it's the point in the middle where it's moving around. Well, no, actually, yeah. Let's see what they did. Yeah, in the middle. Okay. Part 3. Oh wait, drop. Oh, actually, this is what I drew here is actually the answer for part 3. I think. And this is the answer for part 1 and for part 2. In part 3, they wanted the diagram for the amplitude. Oh, no, sorry, I'm misreading. My English is quite bad today. No, this isn't part 3. It's still part 1. This is A part 1, and this is also part 1, and also part 2, and now on to part 3. The part 2 is this part here, the label. Okay. In part 3, they want you to draw the second harmonic. Right, let's try this. Antinode, antinode. Wait, no, hang on. Let me think. One full wave, is it? Yes. So here is a node, node, antinode, antinode. Okay. And let's draw the diagram for number of particles and the X here. So where will most of the particles lie?
those two
the two nodes here. So you have no particles, then some particles here, then oh, this is an antinode as well here,
You have
isn't
to
it?
draw both. That's the particle displacement basically.
Yeah, now in the marking scheme they don't bother to draw this, so you can actually still get full marks with just this, but I want to draw this because they asked me to draw it, even if it's not in the marking scheme. So this is like, it's like the sand.
But are we supposed to draw it like that or like that?
Like this.
Because you see like it has a pointy point.
Oh my goodness, we don't care about that much detail. Yeah. Okay. Look at this picture here. In this picture, what is the wavelength? Well, this is one wave, isn't it? So the wavelength is 0.85. And in part 4, they tell you what the frequency is, the velocity is 340. So they want the frequency. Well, that's easy. What formula do we use? V equals lambda f. So f equals
340 meters per second, right?
400.
Oh.
For this one. Now, maybe Grace, you did it for this one. So if you did it here, what's the wavelength? It's not 0.85.
Half of.
It's half of. No, it's twice of this.
Oh, yeah.
Yeah. 1.7.
The velocity of sound is
340.
meters per second.
Yeah, so the frequency here would be. This one 200. No, 800, I'm sorry. Okay. See, I like this question in the exam. It's not so difficult, right?
Yeah.
Now, next part is English.
Next part is not so friendly.
No, not so friendly. Grace,
Yes.
explain interference.
Interference
Yeah.
is when two or more waves combine to form a new wave, and the particle of superposition
Yes.
states that next amplitude of new wave at each point is the
The
sum
sum,
of the
yes.
amplitude of the individual waves.
Correct. You remembered that perfectly.
Yes.
Okay. Hareen, do you remember path difference?
No.
Now, if you remember, path difference is you have two. Yeah. Go for it, Grace.
For each wave travels different in the distance of each wave travel.
Yeah, path difference. You remember you have two waves in phase, and they meet here, and the path difference is the difference in their two journeys,
Okay.
as Grace said.
But what's the difference?
It depends on their angles and many things. But path difference is the difference in the length of each distance the waves traveled
Until they meet each other.
after to where they meet. Yeah. Coherent waves?
Two wave chords are something. I don't know what that is.
What?
I don't know. You have a look?
Two wave sources are coherent if they have a constant phase difference. Yeah. Do you remember phase difference?
No.
Okay. You need to check your notes or watch the video to get the definitions, okay? And last is phase difference. Yes, go for it.
Phasing SINUSOIDAL.
Say again.
SIN. Yeah.
Sinus. SIN. F-U-N.
Something function or in ways has two different but closely related meanings.
Did I give you this definition or did you get it on the internet?
Internet.
Ah.
I didn't find it in the book actually.
Yes, it is in the notes. Phase difference is this. When you have two waves, like this, phase difference is the distance between the peaks of the two waves. This is the phase difference.
Ah.
You found it?
Yeah.
Yes, good. So part B is definitions, and finally part C.
Can we draw like diagrams to explain?
To help you explain.
Okay. Do we get marks for the diagram?
No. Maybe. I don't know. Yes, part C.
Uh-oh.
What?
Function physics.
No, it's not. In Young's double slit experiment, you have your wave. Okay, so you have your slits here. The D equals 0.15 nanometers, and the wavelength is 450 nanometers. And then you have your screen here, and the waves come out, and they have here a center, 1, 2, -1, -2. Oh, 3. Oh, so easy. All they want here is this angle theta. So what's the formula? N lambda equals d sine theta. Oh my goodness, so easy. Sine theta equals n lambda over d, which equals
Why 0.15?
is it not 0.15?
Oh yes.
Oh,
Yes.
millimeters, not nanometers. Millimeters. So here I get sine theta equals 0.009. So theta is only 0.516 degrees. I better check that. Yeah, only this.
What's the T?
The distance here between the slits.
Shall I then change nanometer to millimeter?
No, change nanometers to meters and millimeters to meters. Yeah. Feel ready for your exam?
I feel even less prepared.
It's worse than before.
No. Which was your best answer? 1, 2, or 3? Mechanics, electricity, or waves? Waves. Yes. So waves should be your favorite, yes?
Actually, no.
Electricity?
None of it.
No, really, which was best?
Everyone has a problem.
I know everyone has a problem.
Yeah, overall from section A and section B is electricity. But I hate it.
you should learn to love it, I think is the best question. Yeah?
I don't have to solve it.
It's the pole for
Don't be
thing,
lazy.
you know? It's the pole thing where it's like that thing.
Which thing?
It's
The pole?
Yeah.
Which pole?
There's like a stick thing, and then there is like a like at a distant one and stuff.
I don't know what you're talking about.
Never mind.
Okay. Wait, before I stop the video, is there any questions from this practice revision questions?
No.
Are you sure?